Okay, so I've been trying to tackle the storage of arbitrary items problem here. This is basically the test rig per se, or however you want to say it. It's just got a whole load of different items, and it's getting kind of forced at the the experiment at the highest velocity possible. Here's 15 yellow belts, and they're going at something less than full, but you'll see why shortly. So, Factorio here, we have obviously some inputs and some outputs here. The idea is that because we're trying to store things and keep them, out of our way, input will vastly outmatch the output, and the output can be chosen by this circuit here. So if we go in here, the first thing you'll see is a balancer. This is not like a technically sound balancer. This is really just like a slapdash way of getting at least some mixing and balancing of the belts. So this is the balancer tier. This is the only balancer that you'll see. The next is what I call the recursion tier. This is just a set of Factorismos with the same contractor as the same contract rather as this here. Only there's two of them in here, and they get split into two. So you'll see if we go into this layer here, it recurses again. You see, it's actually the same exact layout. But if we go one more in, you'll see there's this what I call the storage tier, and we'll get to the storage tier in a minute here. But just like any kind of recursion, you could be going, from the top level here, and then have a leaf node, which would be this storage, or you could go into another recursive layer. These could get really hard to navigate, I'm not gonna lie. But the storage tier is meant to be the bottom layer. It's the leaves, and it just takes stuff in and stacks them into these warehouses. I'm actually seeing there might be a problem with this blueprint, but I'll have to check this out after the video. But this is really just regular inserters in and filter inserters out. And this is where the circuit network comes in. This input here is really simple. It just sets the filters for every single filter inserter, and if there's anything in any of these warehouses, the filter inserters on them will put them onto the outbound belt. So when you're operating this thing, there's going to be quite a bit of delay. You'll see that there's a background kind of level of wood here, because there's actually a certain amount of wood just coming in on this stream. But this is barely getting any right now. So if we wanted to switch this to, say, green wire, we could do that, and then it will be putting out wood for quite a while. It'll be putting out wood for probably another minute or so. Probably going to fast forward this part for you. And the green is starting to show up. Obviously, if you wanted to switch it off like this, you wouldn't want it to mix. So you would either want to put something at the end of this that can filter between the two things that you care about, or you can turn it off for a while with no signal. And if there's no signal, then eventually the outbound belts will be empty because the filter inserters won't have anything on their white lists. So as you can see, it did take quite a while for the green coils to stop going in, even though it's pretty much instantaneous that the filter inserters stop doing their job when the signal is off. It's just because of the belt lead time, and it's probably jamming up a little bit in the belts there. So it's just something to worry, just something to think about. One last thing to look at here is there is a way to see the most populous items in the structure. I say most populous because the signals are not all going to list here, but the red wire here has been wired up to every single silo or every single warehouse, and it all adds up. So 50,000 rail, 50,000 underground, etc., etc. So this could be useful for the period in which we're trying to go from producing a good that has a byproduct. Of course, this only applies to solids. One would have to make an analogous system for fluids, and that would be tremendously complicated, but I don't think impossible. But this should allow us to store stuff that we're not actually using, and not have to go and empty silos by destroying them.